Today we are going to talk about the average value and the mean value theorem for integrals. Average value and mean value theorem for integrals. Now before today, you've had another formula that dealt with average something. What's the other average formula we've learned in this class? Average rate of change. Very good. Okay. Have you learned another mean value theorem before? Yes. And the two of those were tied together. We're going to talk more about that later. How the average value and the mean value theorem are tied together. When we're dealing with integrals, they're tied together again. Because what does mean mean? It means average. So average and mean the same thing. Therefore, that's the tie together between the two. Average rate of change and mean value theorem for derivatives are tied together, just the way these are. So today we're going to do two things. If you look at the board, it says we're going to learn the formula for average value of a function, just like you learned the formula for AROC. Okay, do y'all remember what the formula for AROC is? Okay, we'll talk about it later. And we're going to use that formula in the mean value theorem for integrals. So by the end of class, you're going to be able to and then find the location of the average value using the mean value theorem. That's what the mean value theorem is for, finding out where the average value occurs. All right? We'll talk more about what exactly an average value is in just a moment, but right now let's go ahead and give the formula for average value. So, go ahead and write this down. Average value. I'm also going to be introducing a new vocabulary word to you as we do this. This is the definition / formula. If f is, and here's the new word, integrable. Okay. What do you think is the pronunciation of that word? Okay. It is not integratable, it is integrable. It sounds kind of funny. It's like the first time you ever said asymptote. Kind of giggle a little bit, asymptote, that's a funny word. Integrable, okay? Does anybody have a guess what it means?
To be integrated.
To be integrated, able to be integrated. We learned a word first semester, able to have its derivative taken. What's that word? Differentiable. So, differentiable is for derivatives, integrable is for integrals. All right? So, if f is integrable on the closed interval from a to b, move this over just a little bit, comma, then its average or mean value on the closed interval from a to b is the following formula. Now wait just a minute, let you catch up with me. Its average or mean value on the closed interval from a to b is a formula I'm about to share with you.
So is this a new theorem?
This is a new formula. So when we put it in the flip chart, it's going to be as a formula, not as a theorem. Okay? So AB parentheses F, average value of F is equal to 1 over B minus A times the integral from A to B of f of x dx. 1 over B minus A times the integral from A to B of f of x dx. Okay. Now that's a nice little formula. But I want to talk for a few minutes about where did it come from? What does it mean? Okay? So, let's say we have a function right here. Move it up a little bit. Here's A, here's B. I have a curve that goes like this. Okay. The average value means the average y value. How many y values are there between A and B on my curve?
Infinite.
An infinite number. And how do you average things together? Add them up and divide by how many there are. Can I average an infinite number of values? In reality, no. But with calculus, I can. So what you're calculating here is the average of all of the y values between a and b. Now, how are they doing that? Well, here's how they're doing it. Let's take a look at a very simple curve. Here's a, here's b, but instead of a curve, it's a straight line. Okay? Let's say that straight line is at 6. Can you tell me the average value for that graph?
6.
It's 6. Do you agree with me? The average value is 6. It's pretty obvious that it's 6. Okay. The average value in this instance also happens to be the height of the rectangle that you see. Do you agree with me? Okay. So let's shade in that rectangle. Now, look at the formula. Do you see this right here? What does that calculate for you? Doesn't that calculate the area under a curve? Yes. Okay. If I know the area under a curve, and what does b minus a calculate for you? What is b minus a on this picture right here? It's the length of the base. Agreed?
Yes, ma'am.
Okay. So this formula says I'm going to take the area and I'm going to divide it by the length of the base. And when I divide those two things, what do I get? What do I get? When I take an area and I divide it by a base, what do I get? The height. Because base times height equals area. So if I take the area and I divide it by the base, it finds the height, and the height happens to be the average value. Okay? So let's come back over here to this one. That has a lot of different heights in it, doesn't it? Okay? Let's pretend for just a minute that this is a rectangular box that has sand in it. Sand that you could mold into a sand castle. And the sand, the top of the sand is shaped like this. Could you turn that sand into a rectangle? Yes. Okay. So let's see where that would be. That would probably be about right here. Would you agree? Isn't that about the point where the sand would level off? Okay. So is the area under the black curve the same as the area if I flatten it out? Yes. So it doesn't matter whether the line is straight across or if it's curved. It can be made into a rectangle to where this calculates the area, this calculates the base, and the height, h, happens to be the average value. So when I flatten it out, that number is the average value of the function. Okay. Here's another way to look at it. A minute ago we said that when you average something, don't you add up all of the items and divide by how many there are? Yes?
Yes.
Okay. So let's pretend for a minute that this rectangle is full of an infinite number of lines, vertical lines. Okay? Each one at the top has its y value. When you integrate, you are adding up all of those lines. And then how many lines would there be? There would be b minus a lines, because that's how far long your interval is. So this is the dividing by how many there are. So add them all up, divide by how many there are, averages. So that's another way to look at it. So if the area way makes sense, think about it that way. If the average way makes sense, think about it that way. Okay, now what we're going to do is we're going to actually do the math. We're going to take a problem and we're going to find its average value, and we're going to look at it on the calculator as well. So please write this down. Example 1A. Find the average value of f of x equals 4 minus x squared on the closed 0 to 3. Find the average value of f of x equals 4 minus x squared on the interval from 0 to 3. I'm going to scoot this down just a little bit so you can see the formula. Okay, so basically all I'm going to do is plug it in the formula and chug it out. I know what f of x is. It's right there. But what are a and b? A and b are these two numbers they gave you, 0 and 3. There's your a and your b. Okay? So, to find AV of f, we're just going to plug in everything to the formula. So 1 over 3 minus 0 times the integral from 0 to 3 of the function 4 minus x squared dx. So I just plugged everything into the formula. Okay. On the homework paper, there are some problems that have a little calculator out to the side. And those are the problems that I want you to actually put into the calculator and do the math. This is not one of them. We will do one before the end of class. But this is a problem I want to do by hand using what we learned last week, the first fundamental theorem of calculus. So I'm going to scoot this up now that we're done with the formula. And we're going to do the math. So this fraction out front is 1/3. So just write it down. Open a parentheses. Now remember, the first fundamental theorem says that we're supposed to take the antiderivative of both of these. So what's the antiderivative of 4? 4x. Minus this one, the x is going to increase in power because integrals increase, so it's going to be a 3 and a 1/3 out front. Do you agree with me? Close your parentheses, do your back bracket, and bring over the 0 and the 3. Okay. I know that the 1/3 was outside the integral to begin with. But when you go to plug your numbers in, you can just bring it alongside as you do so, and that's okay. You're going to get the same answer. Now, my next question is, which number do I plug in first, 3 or 0? It has to be the top number, 3. So 1/3 parentheses, 4 times 3 minus 1/3 of 3 to the 3rd. There, I'm plugging in the 3 for everything. Minus 1/3 parentheses 4 times 0 minus 1/3 of 0 to the 3rd. 3 goes first, 0 goes second, you subtract the 2. All right, so 1/3 of 12 minus, here you've got to do the power first, so 3 to the 3rd is 27, and the 1/3 of that is 9. Minus, now, what is the first one? What is this parentheses going to clean up to be? It's going to be 0, okay? Some of you probably saw that right off the bat, and that's okay. But for the AP exam, it's very important that you write down a 0 to show that you knew it was 0, you mentally plugged it in, and you got 0. So that's fine. So you could just mark that out and put 0. You could have written the first line and then just put minus 0, and that would have been just fine. So this would be, so this is 1/3 of 3, which is 1. Okay. Now, it is very, very important that you understand that this is a y value, not an x value. You have just found the average y value for that curve on the interval from 0 to 3. Now, you don't have to do this with me. I'm going to show you real quickly what this looks like on the calculator. 4 minus x squared from negative, wait, no, 0 to 3 is what I wanted. Okay, so here is the curve that we dealt with. So we have this curve, 4 minus x squared. I made my interval go only from 0 to 3. Some of the curve is above the x-axis and has positive y values. Some of it's below the x-axis and has negative y values. But if you average it all out, the average y value is 1, which is about right here. Okay? Now, is there a place somewhere on that graph where the y value you know for a fact is going to be 1? Is the y value going to hit 1 somewhere?
Yes.
And the answer is yes. What you have just told me is basically what the mean value theorem for integrals says. There will be a place on the graph where the average value is a y value for one of the x values on the interval. Okay? The mean value theorem says that the there is going to be a location where the average value is a y value, okay? I'm going to go ahead and type it in at 1. We're not going to calculate it, we're just going to eyeball it. So it's about right there. This is crossing at 2, so I would guess it's probably about 1.8 where it's going to be, the value. And we're going to actually manually calculate it in just a minute. So what I want to do now is write down what the mean value theorem for derivatives actually, for integrals actually says. So MVT for definite integrals. And this will go in the flip chart under the theorems in a couple of days or so. We'll probably do it on Monday. Here is what the mean value theorem says. It says if f is continuous on the closed interval from a to b, comma, then at some point c on the closed interval from a to b, the following will occur. Now I'll let you catch up with me. If f is continuous on the closed interval from a to b, then at some point c on the interval, f of c will equal 1 over b minus a times the integral from a to b of f of x dx. F of c equals 1 over b minus a times the integral from a to b of f of x dx. This right here is the formula we just came up with. This is the average value. So it guarantees that somewhere on your interval that there is going to be a c value that tells you the location of your average value. So I'm going to write this in more simple terms at the bottom. This calculates the location or the c value of the average value. So basically that's what the mean value theorem does. Once you find an average value, it tells you where it is. Does anybody need more time before I go on to a new sheet of paper? Okay. Now let's use the mean value theorem to do a problem. And this is going to be example 1. We have a continuation of what we just started on the other side. We had the function f of x equals 4 minus x squared on the closed interval from 0 to 3. And the directions say find c using the mean value theorem for integrals. Find c using the mean value theorem for integrals. All right. Now the formula says that f of c is equal to the average value. So if you haven't already found the average value, the first thing you've got to do is find it. Already did. It was on the previous page. Average value from the previous page we got was AV of f was equal to 1. We got that the average value was 1. And this was found in example 1A. So when you look at your notes later going, how did you get that? The way I wrote it looks like I wrote ARF. So AVF, it's like ARF. No, it's not it's not a dog. Okay. Now, the question here is saying, if this is the average y value, how do you find the x value that goes with it? That's an algebra question. Let me say it one more time. If I tell you that the y value is 1, how do you find the x value that goes with it? Plug it into what? Into the original equation for what? X or f of x? This is f of x. So the way we're going to do this is you plug in the average value for f of x. That's the methodology. So all you do is you take your function 4 minus x squared and you set it equal to 1. And solve for x. This is all algebra. So I'm going to switch the x squared, and it will be x squared equals 3. Do a little mental math, move everything around. So we take the square root of both sides, and we get x equals plus or minus the square root of 3. Okay, according to the theorem, however, it says that the value of c has to be on the interval. Our interval is 0 to 3. Are both of those answers on the interval? No, only one of them is, and that is the positive value. So therefore, c is going to be the positive square root of 3. Any questions? Okay, before I let you loose to do a problem off the worksheet, I want to take and look at the mean value theorem for derivatives one more time for derivatives. And I want to compare the two mean value theorems and show you what they have in common. So draw a line, and let's write it down real quickly. We're just going to write the formula down. MVT for derivatives. And this happens to be for problem number 1 on the worksheet. You're going to need it. The mean value theorem for derivatives says that f prime of c, that's a little bit different, equals f of b minus f of a over b minus a. That's what the mean value theorem for derivatives says. What is another name that we give to the right side of this equation? It's AROC. It's the average rate of change. And what's the right side of the equation? The left side, excuse me. That's IROC. Okay? So, what I want to do is I want to put this formula back up here. See the two formulas? There's one here. That's the one for integrals. Here's the one for derivatives. Okay? I would like you to turn and talk for a couple minutes, and I want you to compare and contrast the two formulas. Okay? I want you to find one thing that's the same and one thing that's different. Ready? Go. Okay. Let me talk to table 10. Give me one thing that's the same between the two formulas. Somebody at table 10, tell me. One thing that's the same between the two formulas. What do you see? Very good. They both have a divided by b minus a, don't they? That's exactly right. Okay. Anybody else have a comparison? Let me see. Table 2. Do you have anything different? What did you see that's the same? Nothing? Okay. I heard. Who else has one? Somebody be brave and tell me. Okay. I kind of tried to write it in red. Do they both have an average something at the end of the equation? Yes. Do they both have a C?
Yes.
Yes? Okay. Now, what is different? Table 1. What do you see that's different?
It's a f of c and not an f prime of c.
Yes, that's a big one. Please don't get these confused. When you're doing the mean value theorem for derivatives, you use the derivative set equal to AROC. For this one, for the average value, you set the equation, the original equation, equal to the average value. That's a big difference, and it's a very important one. Alyssa, do you have one?
Yeah, for MVT for derivatives, you have to plug in numbers, but for the inflows one, you're using the inflow of the initial.
Very good. For the derivative ones, you're plugging in numbers, but for this one, you're actually taking an antiderivative. That's very good. Okay, so you've seen the similarities and differences. They both deal with average functions. All right, now what I would like you to do is pull out your worksheet, please. Even though the worksheet says do your work on another sheet of paper, I'm going to let you do this one problem on the worksheet because it doesn't take a lot of writing. I'm going to make a couple of notations and changes. The homework tonight is only 1 through 5. And I'm going to do number 5 with you. Okay? Please note that on number 1 is the one that uses mean value theorem for derivatives. So I would change the directions to say find the value of C because that's the way we're used to seeing it. Do that for number one and for number 2. Okay, number 2 is saying find the value of C guaranteed by the mean value theorem for integrals. That's like example 1b. You have to do 1a and 1b. You got to find the average value and then set that number equal to the original equation. Notice these two have calculators next to them. They want you to do the math in the calculator. And I'll show you how in just a minute. Number 3. Number 3 just says find the average value. It doesn't want to know where it is. It just wants to know what it is. That's example 1a. So if you have something to look back at to know what they want you to do. Okay? What I want to do with you is number 5. So I need to push this up so you can see it. Notice it's a calculator question, and that's why I want to do it. Part of the reason I want to do it. It says, in a certain city, the temperature in degrees Fahrenheit T hours after 9 a.m. is approximated by this function right here. Find the average temperature during the time period from 9 a.m. to 9 p.m. Okay. When you see the word average in a word problem, you have 2 choices to choose from. This is either going to be an average rate of change problem or an average value problem. And they're not going to come right out and say find the average rate of change or find the average value. It will be disguised within the way the problem is written. So I want you to, with your table, talk for just a minute looking at this problem and decide whether you think this is an average rate of change or an average value. Talk to each other. I want to just do a general show of hands. How many of you think this is average rate of change? Let me see your hand. Average rate of change. Okay. How many of you think it's average value? Okay. How many of you are still not sure? Okay, most of you voted. Well, I didn't give you the not sure choice until after you voted, right? Okay. So, I heard a very good explanation right over here, and I would like you to say it again. You chose which one?
I chose average value.
And tell me why.
It's because it was the average temperature during the time period, not the average change in temperature during not during the 12-hour difference.
Okay, that is a very good explanation as to why. Now, there will be problems later on that I'll show you where it may not say rate of change of temperature, and it's really a rate of change. So you've got to be very careful. But there's another reason why this is an average value question.
Because it's doing temperature instead of time. The temperature is the Y.
Exactly. This one says the capital T is temperature. And the question says find the average temperature. Could you exchange the word temperature with the letter Y? Yes. If it's asking you to find the average Y, it's asking for the average value. So this is an average value question. Okay? So that's good. I know that it's going to be the integral of T of T dt. Now, since we're doing this in the calculator, let's talk about what the AP wants you to write down. We're not going to type in T of T dt. We're going to type in a Y1. But they want it written in terms of the problem. You also do not need to recopy this function because they already define it to be T of T. So you can just write integral of T of T dt, but there's supposed to be a fraction out front of 1 over b minus a. What is a and what is b? Okay. Some of you are thinking right here, right? Because these are the numbers they gave you. But could it be 9 and 9? No. Okay, we're talking in a 24-hour period. So would this be 9 to, say, 18? The answer is no. Okay, look at what T is defined as. The time is defined as hours after 9 a.m. So what is the T value for 9 a.m.? 0. So this has to be 0. And what would 9 p.m. be? Not 9. It would be 12, right? Isn't 9 p.m. 12 hours after 9 a.m.? Okay. This has to be 0 to 12 because these are how the T's are defined. So it's 1 over 12 minus 0. Okay, let me put the beginning on. This is AV of T, average function of T, or average value of T. Okay, that's what you write on your paper. Now let's talk about what you type in your calculator. Okay, everybody grab your calculator. I want everybody to do this along with me. Okay. Now I need to clear out my y equals. Yours is probably already clear. If you have anything in y equals, please clear it out. All right. You have two options. You're going to be using Math 9. You could type this function directly into Math 9, or you can put it into y equals. It doesn't matter. My personal preference, just because of the ability to possibly make mistakes with parentheses, if it's a longer formula, put it into y equals. It's just a lot easier to do that. So I'm going to see if I can move this over and get a better picture. It shows up better on the video. So in y equals, I'm going to type in 50 plus 14 sine, and I need that fraction bar, so I'm going to put in the fraction bar just because I like it, pi x over 12, close the parentheses. As soon as you're done typing that in, go to the home screen, push second quit. Double check and make sure, especially if you're a physics student, that you're in radians, because this is a trig question. It's going to need to be in radians. Okay. Now we're going to type in this function right here. The 1 over 12 needs to go in the front. So either put it in parentheses or use the fraction bar. It does not matter. So 1 over 12. Move over to the right to make sure you're not still on the bottom of the fraction. Now push Math 9. Type in your 0, type in your 12, and y1 is going to go here. So we're going to do alpha, trace, and enter to put in y1, dx. You'll see what I did. Push enter. Okay. How many decimal places? 3. So I'm going to move this over here. I'm going to copy this down. 58.913. You can round or truncate. Now I'm going to move my calculator. How do I label this? This is the average temperature, so it should be just degrees Fahrenheit. Okay, is that a logical answer? Yes. Please, 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 listen to me. A lot of people tend to put the Math 9 in and then, oh, I'll do the 1 over 12 after I'm done, and they forget to do the 1 over 12. And they get an answer of 12 times this, so that'd be 720 degrees Fahrenheit. Is the average temperature outside going to be 720 degrees Fahrenheit? Maybe on Venus, but not here, okay? Make sure your answer makes sense, all right? Any questions?